I think one of our biggest challenges is actually getting the creative idea from our head to come out on the vinyl exactly how we expect it. There's too many printing limitations there.
We're using white ink, and we're using it in ways that many people haven't even thought of. It's given us the opportunity to knock out reflectivity and to provide a little bit of a texture to the print. It's much nicer to not have to monitor a press all day long.
Hello, everyone. I'm Joe Pryweller, Conference Director for Plastics News. Welcome to Ask the Expert, our new live stream series. Ask the Expert is your chance to engage with professionals, to address the current business environment, to discuss best practices, and most importantly, to ask some questions. The topic of this series is improving operations. Today's expert is Tom Giglio, North American Latex Business Lead for HP Graphics Solutions Business. Tom will take a deep dive into the technology for HP Latex, but will also show how customers are benefiting from the solutions that HP Latex provides. He will answer your questions after his presentation. To submit a question, email pnevents@crane.com, or if you are watching along on YouTube or LinkedIn or YouTube, submit your questions through those platforms. As a reminder, we have 4 upcoming installments this week in our Improving Operations series, including one with IQMS at noon Eastern Time today. And we'd love to have you join us. With that, I will turn things over to Tom Giglio, HP Graphics. Take it away, Tom.
Thank you, Joe, and thank everyone at Plastic News for the opportunity to be here today. As Joe said, improving operations is really the theme of what we're going to talk about today. So with that behind us, maybe we can start our exploration into thermoforming. This is an area that we've really worked on for a little bit here with HP Latex inks. And the way we see it is there's 4 key markets. The first one being outdoor signage, typically printing directly onto polycarbonate that's used for outdoor branding or identification. The second one being gaming, and we see a lot of gaming in the first and second and even tertiary markets for backlit signage, being able to print directly to PETG with colors, but adding white ink to diffuse light and create lots of special effects. We see some really good penetration in gaming. And then thirdly, is point of purchase. Now, point of purchase could be indoor and it could be outdoor, but typically most point of purchase is in retail stores, quick service, restaurants, things like that. And we see a lot of printing onto styrene and PVC and acrylics, again, directly printing to the plastic, heating the plastic, and then being able to form it. And then the last one that I'd like to talk about really is the industrial or aftermarket. And this is kind of like a big blue ocean. This is a market vertical where we see lots of different products, and they could be automotive specialties, they could be luggage, they could be side window deflectors, bug shields, even internal parts for RVs and such. And typically this is printing onto ABS, modified acrylic, and even some polycarbonate, drape forming or forming in general. But if we look at these key markets, we really can improve our operations by printing directly to plastic and then having that ink withstand that. But it's not just that. We try to get through so many barriers, and with that, we'll go to the next slide. And we'll talk about some barriers. And again, most of this market is analog. It takes a lot of time. It takes a lot of trials. And UV ink or solvent ink, which are where a couple competing ink technologies really have been the only game in town. Hazardous air pollutants, VOCs, time needed to outgas before handling. Those have been all a little bit of a barrier because you'd have to print on one day and then form on another. So we can go to the next one. Trade-offs, inks requiring the end user to choose between color, gamut, and ink adhesion. Again, having less trade-offs is a good thing. We can go to the next one about complexity. And that's another thing. Machine complexity is really been a big barrier. People have not that haven't had a lot of digital experience. They've been really perplexed by the complexity of lots of printers and the ability to fix them if they do go down. We can go to the next one. Same thing for process control. High labor, costly to set up, very expensive to rerun, very expensive to get consistency. You can go to the next, please. And then white ink, and you heard me talk about that with gaming. White ink is very far from true white ink. There's lots of chemistry involved in that. And then managing that from a day-to-day perspective is important. And then once we get to the forming stage, which really is the important goal here, lots of other competitive inks require heat bumps. The parts could stick together, and it becomes an awful challenge to form parts. You can go to the next one. And then elongation. Elongation, and we'll show you a couple videos today, just a couple really brief ones to show you that elongation with chipping and cracking has always been a problem. And hopefully we can show how we've improved that operational efficiency by using latex inks. And then the last barrier that we'll talk about is really about image quality. And it really goes into the fact of being able to print good color fidelity, good graphics and images, and then have super, super vibrant colors. So these have all been barriers. And then, people have been able to overcome them, which is great. But in the long run, we want to create some positive and some upside by this. So we can go to the next slide, and we can talk about some benefits. We can talk about some good news. With HP Latex ink, it's a water-based ink, so we don't deal with things like hazardous air pollutants or VOCs. Usually, sometimes you walk into a printer and you're there before you actually get there because it smells like ink. But latex inks don't really have an odor. They're dry, they're ready for handling when they come out of the printer, so they can be formed, they can be stacked, and then the white ink actually can be used on demand without having to do a lot of maintenance. We go to our next benefit, and then less iterations. And this is really what we're trying to do. We're trying to speed up and improve the efficiency and improve the operations by doing less guessing, and then not having to make so many adjustments. So we can print and we can form, we can bring it to market. And when we talked about the barrier of machine complexity, latex ink runs through print heads just like you have an office jet type of printer. You replace the print heads yourself when they wear out. It's easy to do, they get recycled, and they cost about 1/10 of what piezo print heads cost. We can go to our next benefit. And again, that goes on process control, being able to eliminate variables and institute control. So process control is super, super important. And then forming, I'll probably talk about forming again here, but having high temperature resistance, being able to print directly on a sheet, being able to heat that sheet above 400 degrees and have good resistance is super, super important. Again, we'll see that in the video. We go to our next one. And then let's talk about a barrier of image quality. Well, the upside is with latex ink and thermal print heads, you have 1200 by 1200 DPI. You can do multi-layer printing. You can print color and white in a single pass. So again, operators don't have to put several sheets through the printer twice. Go to the next one, please. And then again, with forming, you'll see elongation in the next video, where you'll have great color density and you won't lose that color density. Our white ink is always on demand. It's a very pure white ink. And again, when you're not using it, you take it out of the machine. When you want to use it, you put it back in. It's a non-demand type of feature. Let me go to the next one, which is thermoforming video. So on the left, we're going to show a video. You can roll that now. And this is actually PETG printed with color and white ink. It's coming out of the former. And it's going onto a fiberglass mold. And you can see the latex ink has elasticity. So that's about a 8 or 10 inch draw. It's a fiberglass mold. And then you don't see any cracking or chipping on the edges, but more importantly, you don't see any color degradation. So that image quality really, really stays with it. Now the one on the right, we can roll that one. That is a blow mold. So this is from one of our partners in Europe, and it's about a half of a sphere. And this one, again, you can see that we're stretching this material in excess of 20 inches, but we're not losing any color density, especially in those black areas. So we can put a lot of ink down, and then we can blow mold it, and we can retain the color fidelity. So anyway, those are just two nice things to see to kind of prove the point. With that, we can go to the next slide. And really, this is kind of the ecosystem. Now, with HP Latex inks, it's a very open system, okay? From distortion or simulation all the way to forming. There really isn't a locked path that people follow because there are so many different ways to go and so many different types of business. But from distortion and simulation, matching the image to the mold. There were some partners we have. Same with file preparation, scaling, rotating, getting good efficiency. The substrate selection, working with good manufacturers, some of which are shown here. And then, of course, printing. We have 3 SKUs that fit lots of different needs. But then on the back side of things, we have coating, both the coater manufacturers. And then we also have the coating manufacturers. And again, for different types of durability, that's super important. And the last part is forming. And you can see by the videos, having a good former that's consistent is super important. So again, this is kind of a typical ecosystem, but it is very open. So we can go to our last slide, which is really a thank you. And again, it's thank you to all our friends at Plastic News on behalf of my colleagues here at HP. This is where you can find me. I think this will be shown again. But I just wanted to say thanks for attending today. And with that, I will hand it back over to Joe for questions.
Great. Well, thanks, Tom, for a terrific presentation. Learned a lot about thermoforming and laser printing with this. We're now ready to take questions. To submit a question, you can email pnevents@crane.com, or if you are watching along on LinkedIn or YouTube, submit your questions through those platforms. Here's the first question. Tom, what are the most important steps or considerations for someone who's interested in getting started with thermoforming?
Oh, great question. Great question. So really, the most important consideration, I think, is really to find out where you want to go. It's kind of like when you embark on a trip, and you have to decide, where you're going to go. I tell people all the time, let's look at serving the immediate needs of the technology, but let's look at the step beyond that. Let's look at the markets beyond that and what you don't do today that you could do by leveraging the technology. So that's probably the most important consideration, is really looking at what's in front of you, even beyond that by a step. So I think that's the most important objectivity you could lend to that question.
How difficult is it to make that transition to thermoforming and to do this kind of thing?
Well, it's really not. Most of our customers are thermoformers to begin with. So
Okay.
really augmenting on the front end, a digital solution really is, almost seamless. Nothing is perfect, but again, being very adaptive with a good digital front end but really looking for the type of customer that's, you know, good in forming and has good process control. And then once you have those elements, you're in good shape.
Good. So there's not a whole lot of work that needs to be done to move to digital printing into this use.
No, there's not a lot. It's relatively easy, but it is new. It appears challenging, you know, more so for some people than others. But again, if you have a good ecosystem and you have support resources behind it, then it's actually a pretty fun and it's a pleasant journey.
Excellent. One other question that came in: what types of substrates are commonly used with HP Latex printers for thermoforming?
Well, I like to say we could print on anything, but you know that you're going to have mixed results depending on what it is. But in the plastics world, we see direct printing to styrenes, polycarbonates, PETG, ABS, acrylics, modified acrylics. Those are really the top 6 or 7 that people print on. There are some, you know, some very niche markets that use other sorts of co-extrusions and plastics and things. And again, we're pretty adaptive with that. You know, some take a little bit longer to develop, but in general, those are the core substrates.
Terrific. Well, there's a question that came in through our LinkedIn platform. Can you reverse print those inks onto PETG?
Yes, that's a great question. I love to hear. If you looked at the video on the left, what we had shown earlier, where we stretched basically that cube, that was 0.118 PETG that was reverse printed, and it was printed with color and white ink in one single pass, good density. But even more importantly, the ink contacted the tool, the ink contacted the mold, and the ink did not rupture or crack or chip. So very, very pleased with that.
Excellent. Well, good. I'm glad that question came in. What's the longevity of latex printed parts?
Well, there's a couple things to take that apart with. The first one is for what I just described. If you're doing something for, say, indoor gaming or your second surface printing, the previous question, then virtually that's indefinite because that's going to be used indoor. But at the opening of my presentation, I talked about polycarbonate, maybe printing on certain types of signage or printing automotive type aftermarket things. Typically, some of those are going to require a coating to get good longevity. Latex in and by itself usually is probably 2 to 3 years outdoor. But again, depending on the rigors of the region and everything, it gets a little bit picky. But most of the customers that we have will put a coating on after, and they will get probably 5 to 7 years, and some even in excess of that.
That's great. That's quite a lengthy amount of time with this. With that last, how would artwork need to be adjusted in order to fit a custom shape?
Well, 2 ways. Usually there's, the old school way is to guess a little bit, and there are some people that are super good at it, and they can do that by using some type of reference. Okay, there are other companies like Distortion Arts up in Toronto that actually use a grid system. It's a proprietary grid system where you cycle the grids through your press, and then you send the grids to them. They actually measure those grids, and then they adjust your artwork for you, and they send you back a file. And usually, I mean, I've been very pleased with those results. I've really never had to adjust past that. And then there are other people in Europe, say Quadraxis, who actually make software. So you would print a pattern, take a picture of it, and then it would have plugins for very popular Adobe software to make any adjustments. So those are in effect 2 proven ways to do it, and one other process that works well too.
Terrific. Again, as a reminder, you can send your questions to pnevents@crane.com, as you see from the scroll at the bottom of the screen, or through the LinkedIn or YouTube platforms. Here's a question that did come in from LinkedIn. Are the inks UV stable? Is the question.
Oh, good. These are great questions today, Joe. So,
good.
Yes, the inks are UV stable. The HP Latex inks, even though they're water-based, the pigment particulate or the actual color pigment that is in those inks is an automotive grade pigment, and it does have longevity outdoors. Like I said, in and by itself, it's probably 2 to 3 years based on the region, but yeah, they're fine. Lots of things are printed with UV inks and exposed to the outdoors, and they last very well. Often, actually, the lowest common denominator there is the substrate. The substrate usually is going to break down before the actual stability or color fidelity because of UV exposure.
Okay. So it doesn't matter what kind of temperature environment you're in, whether it's hot, too hot, extremely hot, or extremely cold, or anything else.
No, it could be, it could be a sign in the desert. You're just gonna, usually in the desert though, you're gonna have more sun. So you're typically on the lower end of that 2 or 3 year estimation. But if you're in, the winter and something gets, 20 or 30 below zero, that's fine as well. You just won't get the sun exposure, and you might be more towards the higher end of that 3 year time frame estimate.
Great. Are there any ancillary applications where the technology can be used?
Sure. Even though today's context is really just talking about HP latex and thermoforming or printing directly to rigid substrates, most of what you see in the marketplace today actually happens with latex inks. If you see a truck rolling down the road and it's wrapped, or you see service vans, or even certain cars that are wrapped, a lot of times that's latex ink, because exactly what we talked about today with flexibility and elongation, that comes into play for lots of those technologies. Fleet wrapping is a big thing for latex. The preceding and the commercial that you'll see right after our conversation is about a company that employs latex to do special effects on cars. So just bringing new opportunities that haven't been seen before with new applications is super neat.
Excellent. So a lot of ancillary applications still coming, it sounds like, in the future with this.
Yeah, and it's really, we create the technology, and we like to look at ourselves as enablers. But our customers, we're letting our customers be creative and find the solutions for their customers, and that's really kind of a dual hallmark of a good solution.
Excellent. Question coming in through LinkedIn again. What is the approximate difference in cost of these inks? You knew the cost question was going to come up eventually, I guess, right?
Yeah, well, yeah, and then the general answer is going to follow, right? So,
yeah.
so usually, by nature, okay, and I'll just try to kind of frame this up a little bit. Usually, UV inks or solvent inks are going to be, probably in the $140 to $150 range per liter, okay? And latex inks are usually in the $65 to $95 per liter. So they could be as half as much, or they could be as much as a third less. So really very affordable. Again, not trying to make this a sales commercial, but generally it's a very comparable number, or significantly less depending on what you're comparing it to.
Great. Another LinkedIn question just came in the queue here. Do you have a list of substrate materials that can be successfully printed?
We do. Part of the HP solution with latex printing is really having a locator or a resource that exists where customers, or manufacturers can place different print profiles. Okay, so to ensure compatibility, certification, that everything works, and they can be posted to this locator. The locator right now has thousands of different materials, ranging from wall coverings to self-adhesive vinyl to banners to many of the things we talked about today and all the plastics. So that locator is 24/7, 365. Customers have access to it. So if they want to print on a material, maybe they're not familiar with it, they can download the profile from that locator, and they'll be in business in virtually no time.
And that's on your website, easily accessed via that?
Yes, it actually sits on a platform we call Print OS, which is on every printer that we have, but it's also, you can go to hp.com and you can gain access to it and look. You don't need to have a printer to look, but you do have to have a printer to use the resources that are on there.
You talked a little bit about the time it takes to do this compared to UV inks and other things. Is there a major time difference that we're seeing in many of these applications in printing?
Well, usually that's a great question, because usually when you print, it's kind of a little bit like a drag race. Everyone likes to measure it like a drag race, right? And you want to see how fast you can get down the quarter mile, and you want to see, you know, is my car faster or slower? Usually, Joe, those are about the same. Okay.
Okay.
It's really the technology behind it that gives you the productivity beyond that end game. So what I'm trying to say is, with a latex solution, you are going to be done as soon as that part comes out of the press. As soon as it's printed, boom, it's ready to go. With other technologies, you may have to wait up to a day for that ink to either fully cure or to fully outgas, or even to make the part workable. So again, drag race to drag race, yeah, where everybody's kind of pretty even. But after that, that's where really the productivity kicks in and slants towards latex.
I see. So it's at that. Glad we clarified that. That's great.
Yeah.
Couple LinkedIn questions that have come in from our LinkedIn platform. What special effects can we have with these inks?
Well, there's lots of special effects. And again, beauty is in the eye of the beholder, right? So I probably don't know all the answers to that, because really our customers are figuring those out. Again, in the video that we saw prior to the call, and you'll see again, that company is doing lots of things with opacity. There are print modes that exist on printers. Our printers that have 3 layers. So they have a color layer, a white layer, and a color layer to do different lighting effects with opacity. There's even a 5-layer mode, which actually you can print color, white, black, white, color all in one pass, albeit not that fast. But you can do that, so you can get uniqueness of imagery on 2 sides of different films or polyesters or things like that. So those are just 2 of probably hundreds of effects. But again, there's probably a lot that I don't know of, just because our customers are coveting what they've learned themselves.
Sure. So you can work to customize applications, I imagine, if something is wanted that's a little bit unique in some cases.
Yeah, absolutely. And again, that's why the last slide was really an open system, because whether it's a coating that you're going to add that might have antimicrobial, maybe it's a coating that has anti-graffiti, or maybe it's something on the front end where you're using a pattern to maybe mimic carbon fiber. Those are all types of special effects that can be achieved with this technology.
Here's an interesting question that also came in through LinkedIn. Can these be used for security printing?
If it's holographic, that would probably be a hard no.
Okay.
But if it's printing UPCs and barcodes,
right,
and things like that, that would be a yes. But holographic and patterning, probably a hard no.
Okay. Another application question: are these completely opaque? For example, can LED light backlight a formed unit?
Yes, they can. So specifically for thermoforming, again, without getting into the weeds too bad today on technology, you can create different densities of these inks. And typically, if I was printing a poster, you would print at about 100 or 110% ink density, just for reference, okay? But for thermoforming, we enable modes all the way up to 390% of ink. So you can almost put 4 times the amount of ink that you would normally do for a poster. And a lot of that is built around opacity. And again, if you wanted to shine a light and mask out a certain area, that's where we'd use a mode like that.
Excellent. Well, Tom, that was the last question that came in. We got quite a few nice questions through our LinkedIn platform with this. My last question, I'll ask you if you have any final parting comments to us here about the use of this technology for thermoforming parts.
Well, it's,
Thermoforming.
again, it's a we want to say relatively new. Thermoforming has been around a long time, but being able to match to match a new technology with older methods, I think really has the ability to invigorate and reinvent a lot of companies. We're happy to be a partner with that, and again, I think it's just a ripe atmosphere for growth and incremental growth, and no better time to do that than today.
Excellent. Well, I want to thank you, Tom, for a great presentation and for answering these questions so thoroughly. If you have additional questions for Tom, please feel free to reach out to him directly at the email address listed on the screen below. I'd like to again thank you, Tom, for sharing your insights today, and I'd like to thank you, the audience, for watching. I also don't want you to forget that we have another Ask the Expert on improving operations today at noon Eastern Time. This one with IQMS, and we have upcoming sessions this week. We have one tomorrow with Nexio Plastics on how to realize optimal productivity for improved operations. And Thursday we'll hear from Cannon, Virginia, and then Friday we'll end the week by hearing from Fortify, explaining how to make molded prototypes in less than a week using 3D printed tools. That's it for today. I want to thank you again for attending. Have a great rest of your day.
I think one of our biggest challenges is actually getting the creative idea from our head to come out on the vinyl exactly how we expected. There's too many printing limitations there.
We're using white ink, and we're using it in ways that many people haven't even thought of. It's given us the opportunity to knock out reflectivity and to provide a little bit of a texture to the print. It's much nicer to not have to monitor a press all day long.